Alright, here are some homework problems from 4.5a going over U-Substitution. Okay, so let's look at number 9. We want to first of all, we know we can't expand, so we have to think about potentially having to use U-Substitution. So rewrite in terms of parentheses. So I have 9 minus x squared raised to the 1/2 times negative 2x dx. Identify the u value, so we want our u value to be 9 minus x squared, and we see the derivative, the x, inside or in our integral problem where we can eventually look to cancel out. So u value is 9 minus x squared. Du over dx is equal to negative 2x. Okay, cross multiply, we get negative 2x dx equals du. Solve for dx. Du over negative 2x. Okay, so now we can make our substitution. 9 minus x squared gets replaced with u. Negative 2x gets replaced, doesn't get replaced, so we leave that alone. And then dx gets replaced with du over negative 2x. Okay. The x's cancel out, and so do the negative 2's. But we only require the x's to cancel out. The constants may or may not cancel out. So in this case, they do cancel out. So we're left with the clean problem that we can find the antiderivative. Okay, u to the 1/2 du. Simply go through power rule. So u to the 3/2 over 3/2 plus c. We can resolve the complex fraction. Bring the 3/2 up as 2/3. And then finally replace our u back with our original variable x. So 2/3 9 minus x squared raised to 3/2 plus c. Or you can rewrite this as a radical solution, 2/3 times the square root of 9 minus x squared cubed plus c. Okay, 13. Okay, we want to identify the u value, because if we try to go through expansion, this will take too long for us to expand. So if we allow u value to be x cubed minus 1, then we see the x squared here, which we know will cancel out because our derivative will be a form of x squared. Alright, so we identify u value being x cubed minus 1. Du over dx is 3x squared. Cross multiply, solve for dx. Du over 3x squared. So we go ahead and start making our substitutions. X squared doesn't substitute, so we leave that in our problem. X cubed minus 1 gets replaced with u, so u to the 4th. Dx gets replaced with du over 3x squared. And now we can see that the x squared cancels out. The 3 doesn't, so we have to make sure we keep track of that. Hold it in front as a coefficient. So integral of u to the 4th. So we simply go through power rule, u to the 5th over 5. And then combine our terms here. 3 times 5 is 15, so 1 over 15 u to the 5th plus c. And then replace our u back in terms of x. Alright, 17. Rewrite our problem using parentheses. So 1 minus x squared raised to the 1/3. U value being 1 minus x squared. Du over dx is negative 2x. Solve for dx. And we make our substitutions. 1 minus x squared gets replaced with u. Dx gets replaced with du over negative 2x. And now the x's cancel out, but we have coefficients that we have to keep track of, so we pull that out as negative 5/2. U to the 1/3, we go through power rule. So we get u to the 4/3 over 3. Remember, we're adding 1 to the original exponent, so 1/3 plus 3 over 3 becomes 4/3. Resolve the complex fraction, bring us 3/4, multiply, and replace u back in terms of x. Okay, 21. Okay, there's nothing we can do to expand, and if we did, we would have too many terms in the denominator. We would not be able to split this up into individual fractions. So we see the parentheses here, so we look at the denominator and we set our u value to be what's inside the parentheses. 1 plus x cubed du over dx is 3x squared. Cross multiply, solve for dx, du over 3x squared. We make our substitution, x squared stays. Parentheses gets replaced with u, so we have u squared. Dx gets replaced with du over 3x squared. X squared cancels out. Pull the 1/3 out. So now we have 1/3 times the integral of 1 over u squared. Okay. We have to be careful here because we do want to use power rule, but remember, if we want to apply power rule, our variable has to be sitting up in the numerator. So we have to rewrite this as u to the -2. So now we're ready to apply power rule. So add 1 to the exponent. So u to the -1 over -1 times 1/3. Bring the exponent back down. So -1 over 3u plus c. And finally, u gets replaced in terms of x. Alright, let's look at 23. Again, rewrite our problem in terms of u, in terms of using parentheses. So denominator gets replaced with radical changes to 1 minus x squared raised to the 1/2. Solve for u is 1 minus x squared. D over dx is -2x. Cross multiply, solve for dx. Dx is du over -2x. Make our substitutions. Parentheses to the 1/2 becomes u to the 1/2. Dx gets replaced with du over -2x. X's cancel out. Pull the -1/2 in front. Okay, so now we can look to see what we can do with power rule. Again, just like 21, we have to get this. Get our variable up in the numerator before our power rule can work. So u to the 1/2 goes up to the numerator as u to the -1/2. So we go through power rule, add 1, so we get u to the 1/2 over 1/2. Bring the 1/2 up as 2. Cancels out with the -1/2, so we have -u to the 1/2 plus c. And finally, -1 minus x squared to the 1/2 plus c, or rewrite it in terms of radical form, square root of square root of 1 minus x squared. Okay, 25. We can't, well, it will take too much to expand because we have a cube outside the parentheses. So we want to identify what u value can we choose. And if we look ahead a little bit, this is really t to the -1, and the derivative of t to the -1 is -1 times t to the -2, which becomes 1 over t squared. It's a little more difficult to identify the u value here, but usually you want the u value. If you see two parentheses, you usually want the u value to be the portion that has more complexity or more terms. In this case, the u value will be 1 plus 1 over t. Okay, we want to find the derivative. So we want to get this set so we can apply the derivative power rule. So bring this up as 1 plus t to the -1. Go through power rule. The 1 goes away. This becomes -t to the -2 du over dt. Note that your independent variable is now t, no longer x. So du over dt is -1 over t squared. We cross multiply. We get dt is equal to -t squared du. So this is exactly what we're going to substitute back into our original equation. So 1 plus 1 over t gets replaced with u, so we have u cubed. 1 over t squared, there's no substitution for this, so we leave that alone. We want this to eventually cancel out. Dt gets replaced with -t squared du. So now we look to see what cancels out. The t squared cancels out. Make sure we keep track of that negative, so pull the negative in front. So now we have something clean that we can apply and find the antiderivative. So go through power rule. U cubed becomes u to the 4th over 4. Leave the negative out front, and now I can pull the -1/4 and then replace u in terms of t. So we have our solution here. Okay, 27. Rewrite using parentheses. So 1 over 2x to the 1/2. So our u value is 2x. D over dx is 2. Solve for dx. Dx is equal to du over 2. Make our substitution. So 2x gets replaced with u. So 1 over u to the 1/2 times du over 2. Pull the 1/2 out. Nothing that requires us to cancel anything out. And now bring the u up to the top, so u to the negative 1/2. Go through power rule, bring the 1/2 up, combine, and then replace u back in terms of x. So now we have our solution there. Okay, 29. If we look at 29, this resembles problems that we've seen before. So not every problem in 4.5 will be U-substitution. So we have to kind of get used to considering power rule first, and then if U-substitution is necessary, then we look to that. But here we can simply go through power rule, but first we can expand, write it as individual fractions, subtract exponents because we're dividing like bases. So now, once we have individual terms, we can bring the final x up to the top and get everything ready for power rule. So everything written as rational exponents, all the variables up in the numerator, and expanded, no parentheses. So we go through power rule, and so we have x to the 5/2 over 5/2, 3x to the 3/2 over 3/2, 7x to 1/2 over 1/2. Bring up all the denominators in order to resolve the complex fraction, and then combine terms, and we have our solution here.